Okay everyone, I'm going to go through the answers here via video in case you want to see my reasoning behind all of my steps. So here we go. A school publicizes that at least 61% of its graduating class is employed, making over $30,000 a year. A school counselor tests this by randomly calling 300 graduates and asking if they are employed with a yearly salary of at least $30K. She found that only 164 of the 300 were employed. Is this enough evidence to prove that the school is providing false advertising? So the claim is, the school claims that they are getting at least 61% to be making over 30K. So the proportion that are making over 30K, the claim is that they're at least 61%. And what we want to show, which is HA, is that it's false advertising. It's actually not at least 61%, 61% or more. We want to show that it's less than 61%. So we're trying to show false advertising less than 61% make over 30K. 61% of graduates. Okay, and the school is trying to claim that it is or it's greater than 61%. So you can write it as greater than or equal to because it says at least, or you can write it as just equal to, up to you. Okay, so with that, we're like, okay, now let me check out what I have here. I have a sample of 300 random graduates. And now it says that my P looks like it's 0.61. Therefore, my Q is 1 minus 0.61. And so what I want to double check is, can I make a normal curve? So here's step 1. Step 2 might be labeling. Step 3 is, can I make a normal curve? So I'm going to check my conditions. Is my sample randomly collected or selected? Yeah, that was stated. Okay, it was stated that it was random. Then I need to check, is it big enough to make a normal curve? So 300 times 0.61 and 300 times 0.39. This is about 180, 183. Means this is 117, and that is greater than 10. So it's big enough for normal curve, normal approximation. And then we need to make sure that there's independence. And we check that to make sure, well, one graduate is not going to affect another. One graduate's employment does not affect another. And also that the samples are independent, we check for small enough. So 300 needs to be less than 10% of all the graduates of the school, which is probably true. So we're good. We can make a normal curve. So I'm going to go ahead and do step 4 over here and make my normal curve. So looking at samples, I would expect my sample to show that 61% are making over 30K. Most samples should show that, but samples vary by the square root of PQ over N, square rooted by this standard deviation. .028. And so that's what we're going up and down by here in our graph. So 0.638 or 9, excuse me, etc. You can go up and down by that if you want. And so what I want to determine is, where does my sample lie? Is my sample possible? So my sample showed that 164 out of 300 were making 30K or more. So 164 over 300 is 0.5466. So where is that on this curve? So what I need to do is find my z-score for my sample. So I take my sample minus the center divided by the standard deviation. Take this minus the center divided by the standard deviation. Negative 2.26. So this is my z-score, and now I need to find that p-value. What is the probability of me getting, so I'm -2 and a little bit standard deviations away from the mean. What is the probability that I could get this or lower? So I'm gonna go less than, according to my HA. So I'm gonna normal CDF, -999 up to -2.26 and see what I get. Second bars, normal CDF. .0119. So there's really only like a 1.2% chance that I could have gotten my sample. That's like impossible. So there was like basically no chance that if my original assumption was true, if 0.61 goes in the middle, there's only a 1% chance that I could have gotten the sample that I got. So that must mean that it must not be 61%. So since my p-value, this is my p-value, since my p-value is low, we reject the HO, we reject the HO. Since my p-value is low, less than 5%, we reject HO. This 61 is probably not 61. It's probably going to be lower than that. So we have evidence to show that P is actually less than 0.61. They were lying. They were trying to show that their school is great for graduates, but it's not as good as it seems. We have evidence to show that the percent who make over 30K should actually be lower. There's false advertising. Okay, move on to the next one. You can pause the video at any time and, take notes, make corrections. Okay, the U.S. Department of Labor and Statistics released the current unemployment rate of 5.3% for the month in the U.S. and claims the unemployment has not changed in the last 2 months. So they're saying it has not changed. This is the unemployment rate in the U.S. A test on unemployment was done on a random sample size of 1,000 and found 3.8% were unemployed. Should the state continue with its assumption of no change, or is there evidence to prove a change? So we'll start with our hypotheses. So they're claiming that the unemployment rate is 5.3%, and we're trying to show that it has changed. Okay, so we're trying to prove a change. Technically, change doesn't say less than, and it doesn't say greater than. So I'm just going to say change, meaning it's not equal to what was claimed. And the claim is that it is 5.3%. Be careful when you make it into a decimal. 5.3% is 0.053, and we're claiming that it is not 0.053. So there is a change in unemployment is what we're trying to show. Oops, a change in unemployment. So I always write what I'm trying to show here as like an annotation. That way I don't have to reread the problem again. All right, so now my next step is to label. So my N is 1,000. From my hypotheses, I see my P is 0.053. At least that's what I have to assume for now. which means my Q is 0.9471 minus 0.053. Okay, and I do have a p hat, it's this 0.038, but I'm not going to use that until later in step 5, so I'm just going to ignore that for now. But with samples of this size, can I model it normally? Probably. It says that it's stated that it's random. Stated to have a random sample. So that we know. Is it big enough? Definitely. 1,000's huge, but we'll check it anyway. $53, 947. Those are both bigger than 10. So big enough for normal. Approximation. And then we need to check for independence. Okay, one person being unemployed in a random sample should not affect another person being unemployed. And we can also check that our sample is small enough compared to the population in order to make sure that we are independent. Random sample size. Should the state continue with its assumption? So of the population of the state. I would assume that's true. Pretty much all states have populations over 10,000 people, so we're good. So we can make our normal curve. In the middle, we assume our samples will show 5% are unemployed based off of our hypothesis, which we have to assume is true. So we're assuming that most samples will show 5% are unemployed, but there is some variation. So this is step 4, make our curve. 0.053, 0.947, all over 1,000. .0071. Okay, so that's what we go up and down by, 0.007. So this is like 0.06 essentially. 0.061 maybe. 0.0601. So we're going up and down by that value. And so I want to see, where does my sample lie? So my sample is 3.8%, so that's my p hat, 0.038, 3.8%. Okay, and I want to see where is that on this curve. So how many standard deviations away from the center is it? So I'm going to find my z-score. Negative 2.11. And so I'm negative 2.11 away. Now, I need to figure out, okay, where am I going to shade? So I want to know, what is the chance that I could get my sample if HO is true? And it doesn't say my sample or less, it just says not equal to. Well, not equal to means it can't be less than that, but it also can't be more than 2.11 standard deviations away from the mean. So I'm going to go 2.11 standard deviations away from the mean and shade that. So really I'm looking at the same size tail, just twice. It can't be less than and it can't be more than. So I'm going to go normal CDF. I'm going to find this tail. So this looks like negative 999 up to negative 2.11. I'm going to find this tail. But I have 2 of those tails, so in the end I'm just going to be multiplying by 2. So negative 999 to negative 2.11. and I get this. And so then I want to take that value, 0.0174, and multiply it by 2. And I get 0.0348. Addison, stop it. Sorry, my cat's here. Say hi. Okay. Okay, so still that p-value is low. This is my p-value. And so I'm again going to reject. So I'm going to reject this original hypothesis, and I do think the unemployment rate has changed. There is a change. So I reject HO since p-value is low. So I have evidence to show the unemployment rate has changed. Okay, so that's the first side. The back side, we have one more question and then a review of confidence intervals. So an article in a journal reports that 34% of American fathers take no responsibility for their children. A researcher claims that the figure is higher for fathers in this town of Littleton. A random sample of 225 fathers from Littleton showed 97 who did not help with childcare. So let's run a hypothesis test. Find the p-value for the researcher's claim. So the claim is that the figure is higher for fathers in Littleton. So we want to prove what we're trying to show is that it's higher in Littleton than this article, which says that it's 34%. So we want to say it's higher than that 34%. And what they're claiming is that it is 34%. Okay, so we want to show higher in Littleton. So I'm going to label. My N is what 225 fathers were sampled. My P is 0.34 and my Q is 0.66. Okay, I'm going to check to make sure I can use a normal curve. So I take my N and I'm looking at my sample here. It says stated that it's random. So that's check. We need to check for big enough. Kitty, my cat. Killing me. Okay, 225 times 0.34 is 76.5. And so this is 148.5, both of which are bigger than 10. So it's big enough for normal approximation. We're making a normal curve. Okay, and now we check for independence. I would assume that one random father does not affect another random father, and I'll also check that 225 is less than 10% of all fathers in Littleton. We have to assume that's true. Technically, we don't know. It could be a super small town, but we'll assume that's true. And so now we can make our normal curve. I think I'm actually going to make it down here. So on our normal curve, we assume that our sample will show this 34%, since most samples will show 34%, like our population. But some samples will show a little bit more and some a little bit lower, so let's check it out. Let's find that variation. .0316 or 0.032. I'll do 0.032. Okay, so we're going up and down. Samples vary by about 3%, so you could have samples that look like this. something like this, or they could go down. Down all the way to 24%, or all the way up to 43%. And so we want to see, okay, where does our sample lie? Let's go up here to 5. So our sample showed that 97 out of 225 were not paying childcare, not paying child support, not helping with childcare. That's 43%. So is that enough to show that our P should actually be higher for Littleton, that it's not 34% for Littleton, our P should actually be higher? So what we're going to do is check out our z-score to see if our sample is possible on this curve. So is our sample possible if P is 0.34? So we take our sample and we see where it lies on this curve. So our sample minus the center over the standard deviation. So 0.431 minus 0.34 divided by 0.032, 2.84. Oh man, another rejection probably, because 0.431 is out here. And I want to see, is it higher than that? So I'm going to go step 6, normal CDF, 2.84 up to 999. There's only one tail because we're looking at higher than, so we only want to look at the upper tail. In the last problem we had 2 tails because we didn't know which direction we wanted to go. Didn't really matter. So here 2.84, 999, 0.0023, so which is small, it's 0.23%. So again, we reject HO, and we have evidence to show the percent of fathers in Littleton who do not help with childcare is higher. Is higher than the nation. Okay, it was impossible to get the sample we got with a P of 0.34. So this P must actually be higher to make it so that our sample is possible. So we reject HO, and we showed that that percent is actually higher. So what we're going to do is construct and interpret a 90% confidence interval for Littleton fathers. So using my P hat, I'm going to make a 90% confidence interval. So remember, confidence intervals are like, here's my sample, and I'm like, okay, well, my sample could be off by some margin of error. And this is our margin of error formula. So what I'm going to do is take my sample, but I could be off by some margin of error. We use our z-score for 90%, which is 1.645, and then we just plug in to find that 0.569 all over n, which was, what, 225. Okay, this 0.569 is Q hat, 1 minus 0.431. All right, so I'm going to plug in my margin of error into my calculator. I get 0.0543. And then I'm going to find my two values. First, I'll subtract 0.3777, and then I'll add, and I get 0.485. Okay, so I am 90% confident that in Littleton, 37.7% to 48.5% of fathers don't care for kids. All right, and notice that this interval is completely above 34%. So we were trying to show that the P for Littleton is higher than 34%, and we can see here, interval is above 34%. So it supports our conclusion here, where we rejected HO, and we had evidence to show this. Here I'm also showing evidence of that because my entire interval is above 34%, which shows HA. All right, and that's everything. Hopefully this helps. Good luck.